First of all, I want to thank everybody for taking time out of their busy schedules to partake in this webinar. We've had a lot of very, very good feedback about it over the years. Obviously, we've made some, revisions as the ASTM standard has changed, like the big one that just happened a few months ago, which was the fact that the relative humidity testing has now decreased from requiring 72 hours to now only requiring 24 hours for a documentable result. Definitely a huge improvement. We are going to do a Q&A session here, so if you have any emails or if you have any questions, please email them to us so I can try to answer as many of them as possible. For those of you who don't know me, my name is Jason Spangler. I'm the flooring division manager here at Wagner Meters. I'm responsible for not only the concrete moisture testing side of stuff and the Rapid RH, but I'm responsible for the small line of hand meters that we have for testing wood subfloors and finished wood flooring products. I know that as we sit here and go through these things, sometimes we don't remember all the questions that we have. We remember them later on. So please don't hesitate to give me a call directly at 800-634-9961, and my direct extension is 235 if you have any questions that either I don't get to here or that you think of later on down the road. So without any further ado, one of the questions that I get a lot of times revolves around the concept of relative humidity being a very, very depth-specific measurement. One of the questions we'll get is, how do I know how thick the slab is if I'm supposed to be at 40% of whatever that thickness is if the slab is drying from one side? It's a great question. Obviously, if you're doing renovation work, there's a lot of times where you end up with plumbing that's being added or moved. You'll have trenches that are open, things like that that allow you to be able to see physically how thick the concrete is. They do actually make a device that you can use on the top of the concrete that will send a signal through the concrete and give you a very, very good approximation of how thick it is. That's a positive thing. It's non-invasive. Negative side of it is, last time I checked, it was about $2,500. So unless you're doing a lot of testing, it becomes kind of cost prohibitive to use that or to purchase that device. What I'll hear some people will do is that they will, if they have no other method or no other possibility of finding out thickness, is they will drill a couple of smaller diameter pilot holes through the slab, top to bottom, a couple of strategic places. They definitely don't turn the slab into Swiss cheese. They just want to get some comparative information. Use a wire with a J-hook. You can actually push it down through the concrete, get kind of a close approximation, very close approximation of how thick that slab is in a couple of spots, and then calculate based off of that. And at that point, you've done your due diligence and you've attempted to do the best you can to look at inconsistencies in the thickness overall. So one of the questions that I have here comes from Erica. Are the readings accurate if we accidentally over drill? So if you drill too deep, again, based on the first part of the question that I had from the previous person, it's a very depth-specific measurement. And so if you are deeper than that 40% of the overall thickness of the slab, then the science behind relative humidity testing would tell you that you are actually getting numbers that are higher than what is true. And when I say that, it's not the fact that those are false relative humidity readings. It's just based on the science, that 40% depth, if you drill to that depth, that number you get there with the conditions in the airspace above being at service conditions, those conditions that you get, or the readings that you get at 40%, are the same relative humidity readings that will transfer to the surface of the concrete once you encapsulate the slab. So in essence, when you pour a slab top to bottom, you have less moisture at the top, more moisture at the bottom. When you drill to 40%, you get kind of that average. The problem is that's when it's open to the world. Now, once you put a low permeable membrane on top of it, if the slab's constructed properly, you have a low permeable membrane below the slab, you have the slab, and then you have a low permeable membrane on top of the slab. So you pretty much have taken that concrete and you've encapsulated it between two very low permeable membranes. The moisture really has nowhere to go, more or less, and so it equalizes between the top and the bottom. So instead of being less at the top and more at the bottom, it actually equalizes. And that 40% reading that you get is what that slab will ultimately equalize to. So it allows you to predict what's going to happen on the surface prior to you doing any kind of insulation. Going deeper, it's going to be higher. So that number would not be what the slab's going to equilibrate to. Like Erica has another one. If the hole is drilled too wide, so if the hole's drilled too wide or too big around, then realistically you're going to end up with a situation where the fins on the bottom of that Rapid RH sensor or any of the other products, because the ASTM standard specifically calls out that you need to have some type of isolation fins on the outside of the sleeving mechanism for any kind of relative humidity devices. So for ours specifically, we have 3 ribs on the outside of those fins, or outside of the base sleeve, if you will. The 3/4 inch diameter that you drill is based off of that base sleeve. 3 fins that you have are oversized, and when you push them down, they act as a crush fit. So they actually are a gasket. So they keep it so that you only are getting readings from the bottom side. If your hole is too big around and things aren't sealing it properly, then what will happen is if you have 80% relative humidity in the room, it's going to get down into that hole and the sensor is going to read close to that 80%. So instead of reading that 40% depth of the concrete, you're reading the air. So part of the ASTM standard is that you need to be taking readings of the ambient conditions in the environment where you're doing the concrete moisture testing. There's 2 reasons for that. One is to kind of have some documentation that you're at service conditions when you took the test, because that is part of the ASTM standard also. But the other part is so that you can actually have the information to look at everything together. So if you're looking at something that's 80% relative humidity, or let's just say 60% relative humidity in the ambient airspace, if you're close to that at 40% depth in the concrete, that should throw up a red flag to you that there may be a chance that you're not sealing appropriately. And so instead of actually reading the concrete, air is getting down there and it's reading that. So when you have a close comparative between the concrete relative humidity and the air relative humidity, it's usually something, in my experience, that you kind of throw up a red flag and you need to look a little bit deeper to find out why that is. You'll usually see a bigger discrepancy. You'll see 60% up here and you'll see 85 in the concrete, or something along those lines. Very seldom, in fact, I can't think of one where I've had somebody call me and we've had a discussion about low relative humidity readings, and they've actually not, and when they were close to ambient conditions, when we haven't been able to go back and find out that the device is just not sealing in the concrete appropriately. One of the other questions I get a lot is regarding pan decking. When you have pan decking, first, to clarify, because I still have a lot of people that think because it is pan decking, and especially if they call it vented pan decking, that it is breathing from both sides, which would only require a 20% drill depth for the overall thickness of the slab. A vented pan deck is not breathing enough for it to constitute that. So anything that is on a pan decking of any nature, you're going to drill to 40% of that slab thickness. So then the question becomes, are we talking the deep portion of the slab, or are we talking the shallow portion of the slab? So there, ASTM standard is completely and totally silent. They're looking at some different things there to try to make it clearer for people that are doing the testing, but right now they're silent. So from our perspective, we want you to identify and we want you to calculate based on the overall thickness, or the thicker portion of that pan. So the next question becomes, how do I identify what's the thinner part, what's the thicker part? A couple of people, you could have situations where they may drill a couple of pilot holes to kind of identify where they're at in that corrugation, so that they can identify where that's at, the deeper section, and then measure off of that, because you can see, or you have a spec on what the overall on center is for that metal cladding. The other side of it is people that will buy inexpensive metal detectors that work a lot like stud finders in walls. For under $100, they have devices where you can put it on the concrete, scan across. The signal will be deep enough usually that it'll pick up the thin sections, so it'll pick up the metal on those thin sections. But as you scan across, it won't. It's not strong enough to get the deep section. And then when you hit another hi-hat, as we call it, it'll pick up the second hi-hat. So you can go center to center on these two and drill in between them. Not 100%, but it's definitely something that I do hear people are using out there, and they're using it pretty effectively. So it doesn't look like I have any additional questions. Again, my name is Jason Spangler. My phone number is 800-634-9961, and it's extension 235. If there's anything I can do for you, anything that we can do for you, please don't hesitate to give us a call. Thanks, and have a great day.